So we're going to be continuing our lessons on systems of equations. And today we are talking about systems of equations and three variables. And I'll try and make this short and just do one example question during this video, because I'll also do another one for you during class. So we've been dealing with systems of equations in two variables, x and y. And today we're going to be dealing with three variables, x, y, and z. And if we're doing a system of equations in three variables, it means we also have to have three different equations. And I went ahead and listed the steps so that we wouldn't be spending a lot of time watching me write them down. I highly recommend that you pause the video and write these steps down as we go so that you have them in a notebook. The first thing that we would do, and excuse me just reading through them, I will show you how it all works when we get to the bottom. The first thing you're going to want to do of the three equations is you're going to choose two of the equations and eliminate one of the variables. And I'm going to show you how to do that. Step two, you're going to choose one of your equations and then the unused equation and eliminate the same variable that we eliminated in step one. So if we eliminate y in the first step, then we want to eliminate y in the second set of equations. We're going to put the resulting two variable equations together and solve them like a regular two variable system of equations. And now you have two of your variables solved. And so when we want to find the third variable, all we have to do is plug them into one of the original equations, and then you can just solve it for the other variable. Now, I know that this sounds like a lot, and it is a lot. There's a lot of work that goes into solving three variable equations. Take it one step at a time. Try not to look at the big picture, and let's just go one step at a time. Otherwise, it seems like just so much, right? So here is an example problem, right? We have a three variable equation. Notice there are three equations. I have to have three equations if I have three variables, if I want to solve this. So we have 4x plus y minus 3z equals 45. We have 6x minus 4y plus 3z equals 41. And we have 2x minus 7y minus 11z equals 85. Just for the purpose of you knowing the difference, I always put a line in my z because otherwise it looks just like a 2. And just for the sake of keeping things kind of simple, I put the line in. So the first thing we're going to do is we're going to take two of these equations and solve for one of the variables. So I'm going to take these top two. I'm going to call it A, right? And I'm just going to rewrite them right here. I'm going to take 4x plus y minus 3z equals 45. And I'm going to take 6x minus 4y plus 3z equals 41. Now, I want to eliminate one of these variables, right? I want to either have just xy or xz or yz. And I notice that these are opposites right here. And if I just add these two equations together, my z is going to drop out. So I'm just going to add these two equations together. This is a fairly simple three variable problem because I don't have to manipulate either of these to get one of the equations to fall out. So I'm just going to go ahead and add these. 4x plus 6x equals 10x. Y minus 4y equals negative 3y. Minus 3z plus 3z just is 0. It's what we wanted, right? Our z's disappear. 45 plus 41 equals 86. And so I've done everything I can do with this equation so far. So now I'm going to take, let's say, this equation, and we're going to call it B, and we are going to drop the same variable, which means we need to make sure that we eliminate the Z variable from these two equations. So I'm going to set them both up, my B, and I've got 6x minus 4y plus 3z equals 41. And I have 2x minus 7y minus 11z equals 85. Now, what I want to do when I look at this is I want to go, well, what can I multiply these by to get them to be opposites, right? What is my least common multiple for my Z coefficients? So I'm going to take my bigger number. This is how I always find least common multiple. I'm going to go, well, if I multiply this times 2, it's 22. 3 doesn't go evenly into 22. Excuse me. So I'm going to multiply it times 3. Well, I know 3 will go into 33 because, well, I'm multiplying times 3. So I'm going to go ahead and I'm going to multiply this times 3 to get 33. This will give me a negative 33. So now I'm going to look at this top equation, and I'm going to go, what do I multiply this 3 by to get positive 33? And we would go, okay, well, 3 times 11. So this is going to get multiplied by 11. This is going to get multiplied by 3. And we're just going to rewrite these equations. Now, remember, we have to distribute when we do this. So we've got 11 times 6 is 66x. Then I've got 11 times negative 4. Well, that's negative 44y. 11 times 3 is plus 33z. And then I have 11 times 41. Heck, what is that? 11 times 41 is 451. And then we're going to do the same thing down here. We're going to multiply each piece times 3. So 3 times 2 gives me 6x. 3 times negative 7 gives me negative 21y. 3 times negative 11 gives me negative 33z, which is what started this whole thing in the first place. And 3 times 85 gives me 255. Is that right? Hold on, I got to check my numbers really quick on a calculator. Got 11 times 41 is 451. 3 times 33 is 99. Really? Oh, I don't want 3 times 30. I want 3 times 85. Okay, I'm like, why is that number so off? 3 times 85 is 255. So this is going to be 255. And so when I go ahead and add these together, my Z by design is going to drop out. It's going to equal 0 because we created these two equations specifically so that that Z would drop out. So I'm going to add these together. I'm going to go, okay, well, 66 plus 6 is 72x. These are going to add together and be minus 65y. These drop out, right? 33z minus 33z is just 0. So we have no z. And then I've got 451 plus 255 is going to give me 6 706. So we've done the first two steps, right? We've created these two variable systems of equations. And what we're going to do is we are going to put them together and just solve them as we did the regular two variable systems of equations. We're going to go 10x. Let's make that pretty. Oh, dang. See if I can just 10x minus 3y equals 86. And then we've got 72x minus 65y equals 706. These are big numbers. They're not always going to be big numbers, but in this case, we're dealing with some pretty big numbers. I didn't make up the problems. I just copied them out of a book. So now we're going to go ahead and we're going to follow that same pattern, right? We're going to look at these problems and go, well, what can I multiply these things by that will cause one of the variables to disappear? And let's see, what do I know? If I multiply, I think the best thing I can do is I can look at 72. The closest thing I'm going to get is if I multiply this times 36, which would give me 360, and I know that 72 goes into 360. The best thing for you to do would be like 72 times 2. Well, that's 154, and then okay, well 10 doesn't go into that evenly, and you've got to go until you get something that ends in 0 that 10 will go into. And for us, that is 360, which is 72 times 5. Now, when I do the multiplication on this, I want this to be an opposite sign. Right now, it's positive. So I'm going to multiply this times -5. And the whole idea of this is that we create a same that will drop out, like opposites. So this is going to be 360x minus 360x. There's a bee buzzing around my head right now, as always in this room for some reason. So I'm going to go 36 times 10x gives me 360x. 36 times -3y gives me negative 108y. 86 times 3 gives me, what does 86? I'm sorry, 86 times 36. Sorry, 3 times 36 is 108y. 86 times 36 is 3,096. Really? I want to make sure and check the math on that. 36 times 86. That is right. Then we're going to do the same thing with the bottom, right? We did that one. We're going to go -5 times 72. Well, -5 times 72, the whole reason we did it is because it equals -360x. And then we got -5 times -65. Well, we know that it's going to be positive, whatever it is, right? And that is going to be 325y equals 706 times -5, right? We did this one. Now we're going to go do this one. And we're going to get, it's going to be -5 times a positive number is definitely going to be, then we're going to get 3,530. Will all your numbers be this big? Gosh, I hope not. That is not my plan for you. Hopefully Delta Math will be kinder. And And so now we're going to add these equations together. These are just a two variable system of equations. They just happen to be bigger numbers, right? But when we look at this and we go, well, 360x minus 360x, that's just 0. We no longer have an x variable. Now we have negative 108y plus 325y. And we do the math and we find out that that is just 217y equals 3,096 minus 3,530. That just gives us negative 434. What's awesome about 434 and 217 is that 2 times 217 is 434. So I know it's going to divide evenly when we divide off this 217 that's being multiplied to the y, right? So I'm just going to divide here by 217 and divide here by 217, and I get y equals negative 2. Right? That is a nice bland answer. And the great thing about this answer is when I take it and I plug it into either of these two equations, I can find out what x is. I'm going to use this one because it seems like the math is simpler on it. So I'm going to go 10x, we don't know what x is yet, minus 3y, but we know that y just equals negative 2. So I'm going to go times negative 2. Equals 86. And now we can go ahead and solve this for x. So I have 10x plus 6, right? Negative 3 times negative 2 is positive 6 equals 86. And now we're going to undo everything that's happening to the x, right? We've got the 6 added to it, so I'm going to subtract 6 from both sides, and I'll be left with 10x equals 80. And then I've got 10 being multiplied to it, so I'm just going to divide out the 10. And I'm going to get x equals 8. So we have found two of our variables now. We know what x and y is. The only thing that we don't know about this equation is what is z. And the way we're going to figure that out is we're going to take our x and y value, and we're going to plug it into one of the original equations. So I'm going to come back up here and I'm going to look at what my original equations are, and I'm going to pick one. I'm going to pick the first one, 4x plus y minus 3z, right? So I'm going to write it down here. I'm going to choose 4x plus y minus 3z equals 45. But what I already know about this is that y equals negative 2 and 8 equals x. So I can just plug those numbers in here, right? Y is going to go in there, and x is going to go right there. So I've got 4 times x, well, that's just 8, plus y, well, y is just negative 2, so it's like saying plus minus 2, right? Minus 3z, we don't know what z is yet, but we're about to find out. 4 times 8 is 32, minus 2 minus 3z equals 45. We can combine our like terms. 32 minus 2 is just 30, minus 3z equals 45. We're going to go ahead and start undoing what's being done to that z value. And in this case, that would be, I'm going to subtract 30 from both sides. And I'm going to get negative 3z equals 15. And the only thing we have left is what's being multiplied to z, which is negative 3. So I'm just going to divide by negative 3 on both sides. And I get z equals negative 5. We have a solution now. What is it? We can say x equals 8, y equals negative 2, z equals negative 5. I do not know how Delta Math wants you to enter that yet. You should watch and learn and see how they want you to enter it. The other way you could do it is as a point where you have our X value, then your Y value, always alphabetical order, then your Z value. So you could also write it as a point. That is the only sample I'm going to do because these are super long, but I will do another one for you in class, unless you've already had the class, in which case you've already seen the other one. Let me know if you have any questions. Next time I see you, we will be doing systems of inequalities. So make sure you know how to do this. And that's all.